Good afternoon, students. In this video, we'll see the experiment 2 of the Introduction to Data Science Lab. Our experiment 2 is working with data using pandas. As we know, the Panda is the library that is mainly used for the data science applications. The aim of this program, second experiment, is to write a Python program, work with data such as data selection, data filtering the missing values, deletion of the data, sorting of data, and grouping of the information. All kind of information that is applicable for data science application. The key features of using this pandas is it has a fast and efficient data frame object with the default and customized indexing options. Indexing is there in the data frame and it's used for reshaping and pivoting of the data sets. Group by data for aggregation and transformation. It's used for data alignment and integration of the missing data. The pandas provide the functionality of time series also. In this panda, we can perform multiple operations of the data set such as subsetting, slicing, filtering, group by reordering. Anything can be possible in this panda data frame. The Python panda data structure, there are two types. First one is the series and the second one is the data frame. When you consider the series, it's the one-dimensional array that is capable of storing various data types. The row labels of series are called the index. A series cannot contain multiple columns. It has only one parameter. But the advantage of using the data frame is a way to store data in rectangular grids. The pandas data frame consists of three main components: the data, the index, and the column values. It's a two-dimensional size, mutable, potentially heterogeneous tabular data size. That is heterogeneous means it contains varieties of data, integer data, object data, type, date size data. All kind of data are available in the panda data frame. First one is here I am importing the pandas library. Here import pandas at PD. The library is imported. And then the NumPy is also imported. You know the usage of the NumPy. NumPy is used for the numerical and scientific operation of the numbers. It's mainly used for numerical and scientific operation for these numbers. And then next load the data frame. In my example, I am loading the watermelon data file. Already we know how to upload the data file. Go here and upload. In this, take the data file from your location and upload that. You will get the uploaded data file. After uploading that, verify that that uploaded file is available here. I am uploading the data set watermelon. Watermelon is available here. Then work on with that particular data frame. Here I have created the data frame df. df equal to that CSV file can be read out by using the syntax pd.read_csv. My file name is, my data set is watermelon.csv. Here I am printing the values. You will get the watermelon data set. It contains, if you want to see the watermelon data set, you open this one. The watermelon data set contains 2, 3, 4, 5, 6 touch, density, sugar rate. All these are the columns available in the data frame. We know that the data frame can be, the size of the data frame can be checked by using this df.shape. If we execute df.shape, we'll see the size. Okay, here the shape of the data is 209, 10. First one indicates the number of rows and second one indicates the number of columns. In our selected data set, the number of rows in this is 209 and the column is 10. Then if you want to know the information about the data set, what is the data type, how many values are the to know all the information, we can use df.info. If you execute this df.info, here there are totally 10 columns, 9 are the attributes, the number column, color column, group column, all these things. Here data type is also given. How many values are not null? Not null means the null is not there. It's the value is available. That all can be indicated by using this one df.info. And the next one is Okay, you see the df dot. Next, to find the maximum value and the minimum value for the particular data column can be calculated separately for each and every column. Here I am going to find the maximum value and minimum values. When we execute this one for this data frame is created as the object df. For this data frame, I'm going to find the maximum value of the sugar rate. Okay. So df of sugar rate dot maximum. Find this one and print the value. Similarly, I'm going to find the minimum value for the column density. Execute this one. The minimum value for the sugar rate is 0.469 and the maximum value, so minimum value for density, the maximum and minimum values are calculated from the column and that is displayed here. And the next one is if you want to create a new column with the altered value, that is in each and every column you may perform division or multiplication or the subtraction or addition, everything is possible. If I am going to create a new data column with adding some attributes with it, for example, in this example, density new equal to, I am creating the new column. The name of the new column is density new. That is equal to df of density plus 100. That means from this data frame, the density value is taken and 100 is added with it. And it is stored in the new column density new. And I am creating that one, and for just I am printing the first 5 values. Set of 5 indicates first 5 values. If I execute this query, you'll get here a new column density new is added by the value of density new equal to density plus 100. So this is the density. Density is added to 100 to calculate the new density. And the next one is it also supports the sort by and group operations also. Sort means to arrange the elements. Each and every data frame can be sorted with some key element. For example, I want to sort the values with density. I am going to sort the density value. Accordingly, all values can also be sorted. If I execute this query, you will see the output. So when you see this output, density is the density column. Here, the number column also contains this data 151, 167. That is not arranged because here I am giving this as the density. When you go and check the density column is arranged in the ascending order. 0.233, It's arranged in the ascending order. Same manner, we will display it arrange it in the descending order also. Suppose I want to sort this by descending order. Here I am executing this one. Now you see here the density is arranged in the descending order. According to the descending order of the density, all other data are also sorted. The sort by can be given by using this keyword by, or it may directly given without any keyword. If I want to display only few columns, I'm going to sort the values and I want to display only few columns. Means I'll go for this syntax. Here I am sorting the values, sort values first. This one is executed. Sort values for the density, and only the 3 columns are displayed. These are the values. I'm going to display only 3 values: sound, color, and density, and head of 20. What is the use of this head of 20? First 20 columns. If I execute this query, here in this query, it's given that sound, color, and density is displayed based on the density sorting value. Here density is sorted and based on that these values are displayed. As I have given this head of 20, only 20 values are displayed here. Then the next one is the group by. Group by is used to categorize the data. We are using this group by. If I want to categorize my watermelon data set with root, here I am using this one, group by. df.group by root. Group by root, and count is also calculated. For example, in this data set, there are 3 groups: curly, rolled up, and striped. These are the 3 types of root. Based on that, that's grouped and the values are also displayed. Same manner, if you want to group by the texture, that's also possible. Instead of this root, you use this texture, and the values, number of counts for the particular structure will be displayed after executing this query. This is the structure is blurry, clear, and very blurry. These are the counts based on the texture. The sort by means all the values are sorted, and group by means based on some category, the values are grouped and the count is displayed by using this group by command. And next one is to remove the null values. For that, I have created a new data set with some null values in the watermelon data set. I included some null values and created a new data set, watermelon null. When you refer this one, here there are some null values. Null values means without anything, even 0 is also not there. Here I have deleted some values and some null values are here. So now I am going to count the null values and process the null values. For that, to count the null values, I have created a new data frame with this new data set and the null values. In the null values, is null is the keyword used to find the null values. Whereas if you are printing is null means only true and false, whether it is null or not null, that only displayed. But sum is used to display the number of elements, number of null values in each and every column. Here, after executing this one, each and every columns, the root column, 2 null values are there, sound column, 1 null value is there. The count of all the null values are displayed by using df1.isNull.sum of this thing. Now, I am going to convert. Now, when I check this one, data frame size is same for this one, with null and without null. Now I am replacing all the null values with 0. Null is replaced with 0. So in the root column, so I have taken the root column. Here I have taken the root column, the data frame, and all the is null values are replaced with 0. Here all the values are replaced by 0. You see here, already the value of root equal to 2, null value 2. Now I am going to execute this query. So after executing this one, automatically when you see that the root column, the null value is equal to 0. Initially, the null value in the root column is equal to 2. Now, I have modified the root column null value. I am setting 0 instead of null value. Null value means in the data frame, it can be represented as NaN. Print this one, you may get the clear idea about that. When I am printing this data frame, you see some null values. See here. The root column NaN is there. So NaN indicates this is the null value. If you display here that in this column also, the texture column also NaN is there. If you find this one, some null values are there and null values are indicated as NaN. After replacing this one, the null value, there is no null value in the root column. That means that NaN is replaced with this 0. So instead of NaN, you will see 0 here. Print the value. You see the null value is replaced with 0. The root column, there is one null, already exists one null value. That value is replaced with 0. That's the, you may replace this with mean value, median. This is mainly used for the data processing, pre-processing in the data science application. It can be replaced by any value. And then to append the values means adding the values, to add the values in the end. Initially, the values are appended at the end of the data frame. Here I have created a new data frame. I am not disturbing the old data frame. I have created the new data frame and I have append the values. Can be appended by using this keyword. Color equal to red and density equal to 0.516. In this data frame, there are 10 columns. Even though 10 columns, I am giving values for this color column as well as the density column. The two values are appended. After executing this one, when I am printing this data frame, you see that the last two values are added, 2 columns are added. Initially, there are 209 values. Now it's converted into 211 values. When you see the size, check whether the values are updated or not. There are 211 values. Last two columns, I had added the value. I had added only the color as well as the shape. So color and the density. Here the color and the density is added, and all the remaining things are the null values. So only these two columns are added by using the append. Generally, append will insert the values, include the values at the end of the data frame. Then there exists LOC and ILOC commands. Okay, LOC and ILOC command. LOC command is used to extract, okay, slice the values. It's mainly used for the slicing. It's used to slice the values. Here you see that df.loc of root equal to straight. I have given on Boolean condition. If root equal to straight, extract the values. Root equal to straight, write the value. After executing this one, you see that from this data set, all the values with root equal to straight is extracted. I have given this as straight. So root equal to straight is extracted. Similarly, if you want to extract the values or slice the values with root equal to straight and color equal to light, you may give here and this color equal to light. Then it will also be eliminated. For based on some condition, if you want to slice some values, you go for LOC. The LOC is used for another one application, that is by using this LOC, you can slice some of the rows and also some of the columns. LOC of 0 to 4. 0 to 4 means with the index. Index starts from 0, no? 0, 1, 2, 3, 4. And the columns, texture and roots are extracted. Only 2 columns with this 5 values are extracted. If you see here, root column, texture and root column with 5 values, 0, 1, 2, 3, 4 are extracted. Same thing is used for iloc also, but in the LOC command, here you should give the attribute value, the column names. But in the ILOC column, you can give the column index. Column index means 1 or 2 or the column index can also be given in the ILOC. For example, consider this one. This is the example for ILOC file. In this ILOC, execute this one. 0 to 4, 2 to 5. 2 to 5 means here one thing is the ILOC last in this index will not be displayed. Example 0, 1, 2, 3, 4. Totally I extracted 0, 1, 2, 3 and 4. But 4 won't be displayed here. When you see here 0, 1, 2, 3 will contains up to 3. The last index value will not be included in the sliced value. Again here also 2 to 5. So thinking that 2, 3, 4, 5. It's not the true. 0, 1, 2, 3, 4. Only 2, 3, 4 will be extracted. 2, 3, 4 means here you check 2, 3, 4. Out of the columns, this is 0, 1, 2, 3, 4. Sound, root, sound and texture. Root, sound and texture will be extracted. So the LOC, in the LOC, we will give this column names, whereas in the ILOC, the index can be used for extraction. And the last, another one is the drop the values. Drop means delete the values. To delete the values, use the syntax drop. So I have created a new data frame and I have dropped this one, df3 dot drop root comma axis equal to 1. Here I dropped the, from this data frame, data df3, I have dropped the value root. Okay, root column is dropped. To indicate it is the column, here you should write axis equal to 1. If it is row, no need to give the axis. I already told you axis equal to 0 indicates row and axis equal to 1 indicates the column. If you want to drop the column, you should include that axis equal to 1. It means the root column is removed from the data frame 3 and that is stored in the data frame 4. Now I am executing this one. And I am executing this one. The root column won't be there. The root column won't be there. From the df3, I have removed the root column and stored the content in df4. Now, if I am printing the df3 again I am going to print the df3. If I am going to print this, again here the root column is there. Already I told you I have removed the root column from df3. But afterwards also it's available. It means for that operation, in that time, only one time I can remove that. Then it is permanently available in the data frame. During If you want to remove the column permanently from the data frame, we should write in place equal to true. In the data frame concept, there exists one keyword in place equal to true. In place equal to true, permanently delete the content from the database or data frame. For example, consider here I am going to delete the row. Delete the row means I should give the row indexes drop 1, 4. That is, I am going to delete the rows because I am not giving here axis equal to 1. Axis equal to 1 is not given means automatically it means the row. I am going to drop the rows 1, 4 in place equal to 2. So from this column DF5, I am going to drop the column permanently. So I am using in place equal to 2. Now execute this one. The first column, first and fourth row. The 0th row is there. First and fourth index row. First row is not there. Similarly, fourth row is also not there. These two rows are replaced permanently from the data frame DF5. So if I again printing this value, this one also the values are not there because I have removed permanently. Suppose I am not giving in place equal to true means in this time, second time I am printing that will be available. And then last one is based on some conditions also, we will display the content. DF here, DF1 density greater than 0.345. It means here we are not displaying anything. We are just checking density 0.0343 or not. Yes or not. Yes or no. True or false. So greater than, less than, equal to, less than or equal to. All these are the Boolean operations and that will display only true or false. So when I am executing this one, true or false will be coming. But if I want to print the values, I want to print the root and the color of the watermelon, which is having density greater than 0.343 means separate you should print also. Take this value and print that. That is what executed here. Here, when you see here, I am taking the data frame with density greater than 0.343. If it is true, then print the sound and color of the particular contents. Head of 5 indicates 5 values. So when I execute this one, here I am printing only sound and color of this, where density is greater than 0.343. Here I have print the values of sound and color where density is greater than 0.343. If you want to check that if the density is there, it's easy for you to check that. So you will include the density also here. When you check here, density 0.343, all the values having density greater than 0.343. So these are the basics. So in this video, we discussed how to create the data frame, how to import that Python Panda library, and then how to find the minimum value, maximum value, mean value, median value. To find the mean and median value, print dot mean of df dot mean of df dot median of median value, how to extract the values by using the Boolean operation, how to select the values, how to slice the values based on certain condition or without condition, that is LOC and ILOC. And next one is the drop the values. Drop the column means axis equal to 1 is important. To drop the row value, no need for axis equal to 1. And as well as to append the values, insert the values at the end of the data frame, and how to modify the contents and print it in the new column. All these things we studied in this video, as well as the null values, how the null values can be identified and how it can be eliminated. And sort group, what is the difference between sort and group, sort by descending, sort by ascending. All these things are explained in this video. We'll post the question for this one. Do it. All the best. Thank you.